Today is the day I'm going to try and set up a 10 gigabit internet connection between my editing workstation and my server. It's always been a massive pain editing my videos directly off of the SSDs I record onto, because it means that it's just a pain and I can't use the SSD to record another video if I want while a video is unedited. I have to keep the full-size original files on here. It's just a pain. I really need to move to a workflow where I copy everything over to an SSD array on my server and edit off of that instead. Now, this is one of several 10 gigabit base 10 Ethernet, real copper Ethernet cards that I was sent by a viewer, and I'm very thankful for that, because these are going to be really helpful for getting that set up. Now, today I'm going to be using a bit of Cat 6 that I just ran before I started recording here as the connection between my server. Now, I know Cat 6 isn't the official 10 gigabit Ethernet connection cable standard, but I'm going to try and make that work. I don't have Cat 7, so I couldn't do it if I wanted to. Now, I have a few of these cards. I have one more over here and a stack of them off to the side, but unfortunately it turned out there were some problems with these. So these were decommissioned from servers that were overheating. This fan is not sufficient. I'm actually going to be looking at installing some different coolers, and that's what we're going to do partially today. But it looked like there were actually a couple other issues. Now, in addition to the two cards I just showed you, I was also sent all of these. These are all the same card, which I believe is an X520-T2. These are all 10 gigabit Ethernet copper cards. These are not SFP+, they are true copper Ethernet. Now, I didn't fully investigate all of these when I opened the package or when I was planning this video. I just did it now, and I discovered a few problems. Primarily, this one makes it easy to see. Now, I've marked all of these just so I know for future reference, but there's a big capacitor here missing, a small capacitor here missing, and this one's actually kind of loose. Now, I was able to go back and review the footage from when I unboxed these, and these were loose on there in the box when I took them out. Now, I don't know if these were damaged in shipping or if these were tossed into a scrap pile before. It's unfortunate that that's happened, but now these are suspect. So I don't know when the damage occurred. That one I could see in the video that I opened these from, but all of these that are here have some kind of problem. So this one's marked. What exactly is going on here? Yeah, this resistor is chipped. This chip has been shifted. This one, it's, I believe, missing a capacitor. And this one is, the capacitor is a bit loose there. Now, some of these I could fix. Like this one, I suspect I could probably fix that. I think the trace is lifted a little bit, but I might be able to rerun the trace with a little wire. It's really difficult on cards like these, especially with the massive BGA pads we have going on here. So those wouldn't be the easiest thing, but some of these I'm not really that confident about. There are some easier ones, like that first one I showed you with the chipped resistor. This one would be easy to fix because I could just pull the resistor off of another one of these, measure it, buy a resistor, or just swap it from one that I think I'm less likely going to be able to repair. So these aren't hopeless, and eventually I do want to have more of these set up, or at least something set up. I'm not 100% sure what my final configuration is going to be yet, but I'm not going to be able to get all of these up and running right now due to these small issues. I just don't want to risk putting these in my computers because there could be a shorted problem somewhere. Now, the other two that I showed you, I have thoroughly looked over, and I can't find any issues with them at all. So I think these ones are going to be safe, but still, to be extra sure, I'm going to start out by testing these in a test board just to be safe. Okay, so let's go over my cooling solution. This is the original fan and heatsink that would ship on these cards. This is just a really thin little heatsink with the fins and a fan right in the center. Now, the fan is just going to pull in from the top and blow out all over. It's not managed, and it doesn't really need to be. It's a network card. It is going to get hot, but it's not going to get super hot. Although it does get hot enough, and they knew it was going to get hot enough, that this is an LED that goes to a little spot on the back that tells you when the card has overheated. So it is known that overheating is a problem with these, even when they came out of the factory. But the fans are not doing too great. Now, if I intentionally spin this quickly here, I can hear the bearings. And that's bad on a fan. You shouldn't be able to hear the bearings. So something's not right on these. Probably the fans they've been used up. They're just worn out now. So I'm gonna have to come up with a different solution. Now, this is what I'm looking at doing. Originally, I was advised with some drop-in copper heat sinks that have a really big fan on them, but I really needed these to maintain their one slot size, and the big copper fan would have stuck on top of something like this and made it even taller, so I just didn't have the room in my server to do that. So I'm going with this, and no, I'm not going with passive cooling. I also got some squirrel cage fans, and I'm going to mount this next to here, which has a tube that blows through. Now, obviously, that's not ideal because there's no fins in there, but I can mount it a little bit further down and maybe align these holes. So I'll get a good amount of airflow going through this. I'm hoping that this moves more air through than that does. I haven't tried doing this yet. I cannot hear the bearings on this, just for reference. Definitely can hear the bearings. Cannot hear the bearings. I'm even holding this and I can't even feel the bearings. So, and this is just a cheap fan from China. So yeah, this is going to be a hopefully better solution. This is a bigger heatsink. There's just more thermal mass there. So I'm hoping that helps out. It doesn't mount super well in that it doesn't mount at all. So you can see there's mounting tabs here and here. And I bought a 37mm heatsink because I thought that was going to be the size I need. And it turns out not a single dimension on this thing was 37mm. Literally nothing is 37mm on here. It's not 37mm on the inside of the tabs, the centers of the holes, the width of this, none of it. So that was really frustrating because this is supposed to be a 37mm heatsink, but oh well. So what I did here was I drilled holes in one of the heat sinks. Let me get out a unmodified one so I can show you here. So I took one of these and I just drilled some holes actually in here, and then that allowed me to mount it. Now the other problem is obviously it's the different corners where I want to mount it. So yeah, because if I had it this way, the way that the screw holes are on here, the only place I could really mount the fan is up here and have it blow down into the motherboard, which would restrict airflow, although it's not like it's amazing blowing into the Ethernet ports over there. But I don't know, I kind of like the idea of having it here, although maybe these inductors are going to get hot and damage the fan. I don't know. I'm going to play it by ear here. We'll see how this works out. I don't really know how well it's going to work out, so we're just going to find out. I need to go drill some holes in this heatsink. I'm going to go do that outside of my workspace so I don't have little metal shreds all over. And then I will come back and we will finish up the mount here. Now I still have this fan somewhere. Where did I put it? I tossed it off to the side. I'm going to have to cut off the fan power cable and put it on the squirrel cage because this is a different connector. So yeah, got a lot of work to do. Now briefly before we attach this to the card, I want to just mention that I know I could find replacements for these heatsinks out there. Matter of fact, these have a part number on them, and I've found some people mentioning replacements for these, but this has proven to be inadequate, this amount of heatsink, and I feel that this is more. This weighs a lot more, and it's not just that it's a bigger motor. So I'm hoping that this increases the cooling capacity on these and just makes it work a little bit better. Server parts like this are going to be designed to be used in a chilled server room, which I'm not running this in. So I'm hoping to come up with a bigger, better cooling solution than the integrated little fan heatsink combos like this. So I'm really hoping that this proves to be a better option in the long run rather than just a drop-in replacement. So I'm just going to put this on straight up. Now I do need to put on a little bit of thermal paste there, so let me get some of that on there, and then we'll see how this mounts. Now the spacing on here isn't perfect because again I had to drill holes in this to get the correct size. So it's not the best. I think this one is, these are slightly too far out, and the other one is slightly too far in, but it's, you know, for being hand machined, I don't feel like it was a bad thing. So, all right, there's the thermal paste. And attaching the heatsink. And hey, unlike most CPUs, I can actually get a side shot of this. So let's see. It's not going on very smoothly. There we go. Now for the record, where that screw head is, there is nothing electrically. I mean, yeah, there's that little tiny, whatever U9 is there, in the C3, but those are pretty far up there. So yeah, you can see they're not being touched. There is space. So yeah, all right. Hopefully that works, because I really don't want to have to try and find a different solution. All right, that's both new heat sinks installed, and they are fully down on the chips, so that part's done. Now it's time to move on to the fan connectors, and that's going to be pretty easy because I'm just going to put the cables from the original heat sinks on here. I'm just going to cut them, splice them. Simple enough. All right, there we go. Both are mounted, the fans are electrically connected, and they should be ready to use now. The connector on this one gave me a little bit of trouble because the crimped connector on the end of the wire popped out, so I had to kind of jerry-rig it by melting the plastic around it so it stayed in place. And one of the tension fasteners for the heat sinks that came with these heat sinks, or the ones that came in the bag from China, it's kind of sucked. So I put one of the original ones from the heat sinks that were on it on there. These are kind of better, but they're really thick and difficult to get through the heat sinks. So I mean, maybe I'll have to swap them out later. They also have a pin that locks them, and I like that a lot, so I might want to do that. But I think that's all good. So yeah, now with all that done, it's finally time to test these. So let me go see if I can find a motherboard, RAM, processor, etc. that I can grab to test this out, because I don't want to try throwing one of these in my main computer or server until they prove themselves based on the condition of the other ones. Don't know if, say, something's shorted, and that would definitely cause a problem. Alright, I'm sure this video is going to get a whole bunch of comments about people who are going to complain about my less than official modification here, and how it's not going to work, and that I should just buy SFP Plus cards, and blah 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 blah, all those people getting riled up. So let me throw in a few more things to ruffle some feathers. Here is a Core 2 Duo computer that is, I bought it in 2012, but it's not, I didn't buy it new, so it's secondhand. The heatsink that's on here, the retention that holds it on, two of the pins broke, so I'm just going to have it sitting on there, and yeah, that's thermal paste from 2012, deal with it. The fan on here apparently stopped working at some point between then and now, so I'm going to use this 120mm Noctua fan sitting in a RAM slot, because I don't have any more 80mm fans on hand to swap that out with. And I'm going to be booting a Ubuntu off of a flash drive. So here is our test setup. I've connected the motherboard to a 1 gigabit switch, just going to internet so I can test out that this whole thing works. So let me go ahead and start it up. I found a 1 gig stick of RAM. Let's see, CPU temp 32. So as I'm sure you know, this isn't the first time I've posted this already. It's been fluctuating between 30 and 37 when it's on, so I'm happy with 32 there. So, yep, Ubuntu is Ubuntu. I'm just never going to learn that, so you know what, I'm going to give up. boots up just fine on this. So I'm going to go ahead and shut it down and slap one of these in here. It only has one PCIe slot. The others are PCI. So, yep, let's see if this works. All right, this is my first time powering on any of these 10 gigabit cards or the fan, so I don't know how loud that's going to be or how much air it's going to move. But let's see if this works. So the fan's not that loud. It's moving air. Hopefully that's enough. All right, I can't see the back. Oh, I think it's picking up some steam, or is that the Noctua fan? You know, that might be the Noctua fan. That thing moves a lot of air. Although I can definitely hear that thing picking up speed. Yeah, so far I like the sound of that. I can see that it's just not quite one slot high, so it's gonna encroach on the space of the card next to it just a little bit, but it's plastic, so it won't matter. As long as none of the fan blades get stuck, then it won't matter. So, alright, I'm gonna go ahead and get some stuff going here to see. Well, actually, I should be able to just see if I have two network connections right off the bat. I don't know if I'm gonna be able to get sensors to read off of this in Linux. That would be really nice. Yeah, let me go ahead and play around with this a bit and report back. I have two wired network connections. Sweet. This one reads as a 10 gigabit. It's obviously not connected to a 10 gigabit network, but it's recognized. So yeah, let me go ahead and play around with this now, and I'll catch up with you in a second. Alright, this computer's pretty brutal to use with this version of Ubuntu. So both cards show up in here as a 10 gig card. This one is the first card I tested. That's the second one. It looks like they both connected to the network, so that's fine. But this thing sucks so much that it can't even run Firefox with, again, version 1604 of Ubuntu. So I think the 1 gig of RAM I was able to find to stick in here is just not enough. Oh, now it's pretending like it can run it. Yeah, it's not going to succeed. So I think I'm just going to go straight to full-scale implementation and try sticking one of these in my Z820, the other one in my Supermicro server. So we'll see what happens. For the record, the temperature on here never gets hot enough that I can't leave my finger up against the heatsink, but the heat output from these is dependent on the length of the cable, and that's like a 1 meter cable, so that's nothing. And it's not doing 10 gigabit, and it's not actually transferring any data. So I'm not feeling confident that I'm actually cooling this enough that it's going to be usable. So we'll see how this goes, but I'm not confident at this point. So we'll see. Okay, I've got the card in my desktop, and it is working. I can get data out of it. Well, by data, I mean I can read some information from it over ethtool, see that it's properly connected as a 1 gigabit card because I'm just using a Cat5e cable to a 1 gig switch, so that's what it's going to be. And it looks like it's just doing fine. I'm getting full connection information everywhere. But there is one problem. The ethtool here is supposed to be able to report the temperature of the card, but it doesn't look like this card supports that, which means I'm never going to know what the temperature of the card is. So I won't know if my fix is working and if it's overheating. That's kind of a problem, so I'm not really sure how I'm going to handle that. It does have the overheat LED on the back, but I'm not going to be able to see that on the back of the server, and my desktop really isn't much more convenient to get to than that. So I don't know quite how I'm going to check that. I think I should just start a really long transfer between the desktop and the server and watch for the overheat LED, because I don't really have a lot of other choices. Which means I'm going to need to go get the other 10 gigabit card in the server. So I'm going to go do that now. Whew, okay, it's all set up and working now. The last time I set up a static IP address in Linux, I was using IF updown, not netplan, which is what Ubuntu switched to recently, and my knowledge of IF updown was only hurting me when setting up netplan. So I had a couple of patrons help me, and I'm extremely grateful to them, thank you, because now I have everything fully functional. So first off, let's do this. We'll look at ethtool, and what is it on this one? S60 or 6F1? Is that what it is? There we go. 10 gigabit connection. Bam. Awesome. Okay, and if we do the same thing over here, ETH tool, oh gosh, I think this one's 05. 10 gigabit. All right. Fully functional on both. Now, we can do a test to verify the connection. So we'll run iperf3 server and iperf3 and connect directly to it. Let the test run. That's a lot more retries this time, but hey, it's working perfectly. So 9.38 gigabits per second. That is near enough 10 gigabits per second. That is sweet. Now, unfortunately, the real world is what we live in, so you don't quite get that. Now, if I do an rsync to transfer a video file from the SSD from my camera, which is connected directly to the desktop, which I can just show you here. I'm going to transfer a video file from earlier that I recorded already. So if I go ahead and transfer this over the network to the server, we will see we get at max about 300 megabytes per second, which is unfortunate, but that's just going to be real world speeds. Now, there are two things limiting this. One is the SSD array. So if I write a 0 file to the SSDs, we can see we're getting about the same transfer speed that we were getting. So that's clearly a bottleneck. And if I write to the SSD on the computer, I guess I don't have a command for that ready to rock. Just copy and paste. We can see we get, well, a lesser speed, but that's for write. That really doesn't make sense. I don't know why it's writing so slow. It could be because I don't have a proper USB-C port on my desktop like the SSD is. So anyway, yeah, that's annoying. But fortunately, the read speeds for these are crazy fast. So if we read from it, there we go, 2.6 gigabits per second. That's the speed that matters the most. The read speed from the SSD isn't as important. All right, now here's where it really matters, editing. And I am able to do whatever I want in Resolve with this setup. Now these files are being stored on the server and they are enormous. I mean, look at this, 60 gigs for one of these shots. And if we try and play this back, we'll see that it really still doesn't play back all that well just because it's a massive, huge file. Resolve kind of cheats and does some downscaling as it's playing, but if we play this back, we will see that this is over a gigabit per second in the bit rate for the files. So it's very important that I have a faster network connection to do this. And now this is finally up to par. So after it does a little bit of skipping there, it eventually settles at a decent speed. And really, I can also help it out by choosing a proxy mode that's going to make it a little bit easier on it. But I can scrub through, I can let it stop, and it'll continue playing. This is working very, very well. I am super happy with that result. Now for a comparison here, I've loaded up the same video project, but connected over the 1 gigabit connection to my server instead. And we can see, if I start running it, it's got a lot of choppiness to it. It thinks that it's running at full speed, but you can see how much it jitters. There's just a lot of problems with it. It makes it very difficult to start and stop editing. It kind of scrubs okay, but it just isn't quite there. So yeah, the 10 gigabit connection's going to be immensely helpful. You know, I'm watching back the files as I record them here, and it's really not doing justice to just how much better the 10 gigabit connection is. So I just want to let you know that even if the video here doesn't necessarily look like the 10 gigabit connection is doing better in Resolve, it is in person. I think doing video capture here might be affecting the performance of Resolve's playback, or maybe the playback capture. So just know that yes, in person it does actually perform better. I think what I've got going here with an unprocessed clip, I have nothing done to this, shows it better how well it's performing, because it's totally perfectly smooth. Another problem is when you jump around with almost anything, you have audio issues, and that does not happen with this 10 gigabit connection. The 1 gigabit connection, it was very possible to skip around and then just have no audio while it tried to figure out where in the stream you were. This is much more reliable. Alright, well, I think that pretty much sums up everything for the 10 gigabit upgrade. I have these cards repaired with my less than optimal solution here, but hey, I think it's working. I don't know for certain that these aren't overheating, because the only indication is this little LED back here, and I can't see that when they're in the server or the desktop. So I don't know. ETH-Tool does not report the temperature, so I can't see that. If I start having issues that I think are temperature related, I might solder another LED onto that I can run on wires somewhere else. So there is a way, but it's not desirable. But for now, I'm really happy with this. I do know that this setup is not optimal. Obviously, I'm just using, if you've seen the other videos in this build series, a RAID of 3 ZFS1 partitioned SATA 3 SSDs. It's not NVMe, it's not M.2, so there's nothing super high-end here. This is just a pretty cheap bare-bones setup, which is the idea. I'm not looking to spend $3,000 on storage and connectivity. I'm just trying to do this with what I've got. With this very, very generous thing that I was sent to get these cards, I couldn't do this without those. This was really awesome. I know 10 gigabit copper Ethernet isn't the typical way you do this now, but they're what I have, and they've worked very well for me now. So I'm happy with these. Later on, maybe I could get a faster drive that I could put in the server, because that is the bottleneck. It's the SSDs are the problem. But for now, I'm really happy with this. I hope you guys have enjoyed this process of getting this set up. I think I'm at the point where the server is nearly complete. The only thing left is a GPU for rendering on the server. I still need to try out CPU rendering, but now that I have these cards in there, I'm going to be more inclined to keep all of the video data on the server. So now it's going to be a lot easier to do CPU rendering on the server, because I won't be transferring files all around anymore. So maybe there will be an update on that in the future. I'm also wondering if those 6 gigabit 1060 mining cards could be used in Linux to render videos, because those are really cheap, and I don't need a video output, so that's not a problem. So I might look into that in the future. I don't know. It would also be possibly just wasting money on something that doesn't work, that I don't need. So I don't know. For now, I hope you guys enjoyed this look at this. If you want to support the channel, I am on Patreon, but for now, that's it. I'll see you next time.